Hello, this is a video on naming using one of the major systems for naming ionic and covalent compounds. I just want to dive into this. I want to just start off by naming, actually this entire video strictly deals with what we call binary compounds. A binary compound consists of two parts. If we're talking about ionic substances, we're talking about a metal and a non-metal. Strictly speaking, it's in the binary compound, the less electronegative portion, which normally is the metal, goes first, and the more electronegative goes second. That's a catch-all. If I'm just speaking about ionic compounds, then it's the non-metal that comes first. I'm sorry, the metal that comes first, the positively charged ion, and the non-metal that comes second. It's for that reason that students come in knowing full well that table salt is NaCl. It rolls off your tongue, and you never make the mistake of saying ClNa, because already even what you know reflects the convention for naming. Simple compounds like this are named very easily. There are two parts, again, the metal and the non-metal. If you notice, the first part of the name is just the name of the metal: strontium, barium, cesium, sodium, lithium, beryllium, magnesium, rubidium, and calcium. The second part, the non-metal, is altered to include ide. Ide indicates that you are dealing with a binary compound, and the ide is affixed to the non-metal. Now, the name of the non-metal here is fluorine, and that just becomes fluoride. Chlorine becomes chloride. Bromine becomes bromide. Iodine becomes iodide. Now, nitrogen turns into a two-syllable nitride. Oxygen turns into oxide. Hydrogen turns into hydride. Sulfur turns into sulfide, and phosphorus turns into phosphide. So it's really pretty easy if I just come up with one. If I come up, let's say, with BaCl2, I actually just did that one. Let's come up with a different one. Oh, how about BaSe? This is simply the name of the metal, which is barium. This is one that I didn't mention. This is called selenium, and it is changed to selenide. Or for that matter, if I were to take CS and N, and this is CS3N, well, the first one is cesium, while the second is nitride. Notice I don't have to do anything. I don't have to worry about the three here. I don't have to worry about any subscripts. The name is simply the name of the metal and the name of the non-metal, altered to include the I. Of course, the reason that I don't have to look at the ratios, I don't have to look at the subscripts, is because all of the metals mentioned, these are all group 1 and 2 metals. It would also apply to aluminum, and it would also apply to something like zinc. All of those mentioned metals have only one oxidation state. They only have one charge. Because they have only one charge, my naming is no more difficult than that. But what if I then moved on to metals that have more than one positive charge, more than one positive oxidation state? Well, I've jumped to an exercise. We're still dealing with binary compounds. There's a term called the Stock system. I won't spend any time on that name. It's just a term. I'm just going to give you the practice. I mentioned that the other elements before, like calcium or silver, these only have one positive oxidation state, so they're really, really easy to name with. Now, I bumped into, particularly in the middle section, those transition elements. Copper, if I look it up, isn't just positive 1, it's also positive 2. So a problem would be is if I tried to name CuO, again, the name of Cu is copper, and O is oxide. But unlike in the previous examples, I'm not done, because I don't know whether the copper in the copper oxide has a positive 1 or a positive 2 charge. I have to give another piece of information that simply tells me what the charge of the copper is. And we use Roman numerals for this. I would use a Roman numeral 1 if the charge on the copper is positive 1. And I would use Roman numeral 2 if the charge were 2. Again, I don't have to use a Roman numeral 2 if it's calcium, because calcium's always positive 2. So there's no need to do it. I always know what calcium is. But then your question is, that's fine. How am I supposed to figure out from the formula whether or not it's 1 or 2? Well, I have a simple answer for you, and that's algebra. Well, I'm solving for x. I do not know what copper's oxidation state is, so I'm going to call it x. Now let me take a step back. These are all, you're always dealing with neutral compounds. And so the sum of the positive side and the negative side has to equal 0. It has to be a neutral compound. X is the positive side, and the oxygen is the negative side. They have to add up to equal 0. Well, then I must be able to look up oxygen somewhere. Yes, I can. Oxygen always has a charge in these ionic substances of a negative 2. So that means it's 2 plus, and x plus a negative 2 equals 0. So I solve for x. X equals positive 2. Oh, so that means positive 2, Roman numeral 2. So this is copper 2 oxide. Now let's look at C. Notice C is the same, or nearly the same. It contains, like the previous one, copper, and it contains oxide. I do not know, just by looking at the formula, not directly at any rate, whether the charge is positive 1 or positive 2. So I use algebra again. Now notice this time, I have 2 coppers. So I'm not going to call this x, I'm going to call it 2x. 2x plus the charge on oxygen is negative 2, again, has to equal 0. So 2x equals 2. Divide both sides by 2, x is equal to positive 1. So this is a Roman numeral 1. Let me take you through one other. Let's do D. Now D is called Fe2O3. I know Fe is iron, and I know O is oxide. Am I done? Well, it turns out Fe, like Cu, has 2 possible positive states. If it turns out that this iron has a charge of 2, it's a Roman numeral 2, iron 2. If it's a positive 3 charge, then I'm going to call it iron 3. Well, which is it? Again, guys, I'm going to use algebra. Like before, I have 2 irons, so that's 2x. I have 3 oxygens this time, so it's a little spicier than last time. And each oxygen is negative 2, but as always, they have to add up to equal 0. Well, 2x minus 6 is equal to 0. That means 2x equals positive 6. Therefore, x has got to be positive 3. So this is going to be iron, Roman numeral 3 oxide. Let's move on to talk about the reverse process, where I give you a name and you have to figure out what the formula is. Now I've returned to those group 1 and group 2 metals that only have one possible positive charge. So in each case, I have to go and actually look up what the charges are. Why don't we do radium sulfide? That's a good one. So what I do is I look up radium. Radium is Ra, I need that symbol. And sulfide is sulfur. Now I need to go and look up radium. And when I look up radium, I see it's always only positive 1. So I'm going to assign it a charge of positive 1. Sulfide is, I look it up, and I see it has a bunch of charges, but remember the order is always this. The positive, then the negative. It's minus 2, positive 4, positive 6, but I ignore those positive values because I know sulfur has to be negative. So that's going to be a negative 2. Oh, I made a mistake. I apologize. Over here, radium is in group 2, so this is a positive 2 charge. Sorry about that. Now, I'm going to give you a handy little trick for figuring out what the ratio is. What we do is this. The trick is as follows. I make a diagonal, and I bring this 2 down, and I put it at the foot of Ra. Then I take the magnitude of radium's charge, and I put it at the foot of sulfur. So far, I have Ra2, S2. Now, I have to reduce this to the lowest whole number ratio. Lowest whole number ratio. And a 2 to 2 reduces to a 1 to 1. Let me do aluminum oxide. Why don't I do that one? Aluminum is Al, and oxide is oxygen, that's O. When I look up aluminum, I see that aluminum is always positive 3, and of course oxygen is always negative 2, so I'm going to put a positive 3 here and a negative 2 there. And I'm going to do the same method as before. I'm going to bring this 2 from O to the foot of aluminum. And I'm going to bring this 3 from the charge of aluminum down to the foot of oxygen. And when I clean this up, I see that it is Al2O3. I cannot reduce a 2 to 3 ratio, so that is the formula of aluminum oxide. Now let's return to those that have these Roman numerals that actually come out, they actually help us, they actually tell us what the charge is on the metal that comes before. Remember, they have to, because in a case like vanadium, vanadium can be positive 2, positive 3, positive 4, positive 5, so I absolutely need those Roman numerals to tell me what the charge is. Now, why don't we talk about B, C, and D? What they all have in common is they're all vanadium, V, 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 and sulfide, S, S, S. In the case of the first, the Roman numeral 3 tells me the charge on vanadium is 3. I look up sulfur. What negative charge does it have? Negative 2. So I bring the 2 down here, and I bring the 3 down here, and I have V2S3, and that can't reduce anymore. In the second one, vanadium 2 sulfide, here the vanadium has a charge of plus 2. That's what the 2 tells me. And the sulfur has a charge of negative 2. I bring this 2 here, V2. I bring this 2 here, S2. So here I have V2S2, but we want to reduce to the lowest whole number ratio, so that reduces to VS. Finally, I have vanadium 4. This is telling me the vanadium has a charge of 4. And the sulfur is still 2. Well, I'm going to bring this 2 down here and put it at the foot of vanadium. And I'm going to bring this 4 down here and bring it to the foot of sulfur. So I have V2S4. I reduce it. I can reduce a 2 to 4 ratio to a 1 to 2 ratio. So that reduces to VS2. Well, just a little bit of an overview of this method. It can also work, I have a little bit of time left, even if I have nonmetals. Now I know this is a nonmetal here in J, but because it comes first, it has to have a positive value. So what this means is that carbon is C and oxygen is O, but this is telling me carbon has to have a positive 4 charge. Oxygen, as I've been saying right along, is negative 2. Oh, this one's going to go the same as vanadium one, right? I bring the 2 here and the 4 over here. I get C2O4, but I have to reduce to the lowest whole number ratio, so it's CO2. Oh yeah, carbon dioxide. That's called the traditional naming system. Notice I'm focusing on a different naming system using these Roman numerals. Well, I hope that was helpful. Again, what we did here today is we learned how to name and write the formulas for binary ionic compounds and binary compounds in general. There are other kinds of compounds which I'll do in a separate video, but the general rules of naming have all been laid out here. I hope this was helpful, and bye-bye.